One other little thing I wanted to mention, we're not going to do a lot of problems with it, but it's something which is useful to think about for everyday life cases. One really common case of rotation that we haven't really talked about yet is something rolling across the ground. So like, say for instance, I take this coaster here and I drag it across my hand. You'll notice that it spontaneously starts rotating as it travels. And I am currently trying to very carefully put my finger only in the center of the object. So I'm not exerting any torque on it because I'm exerting a force on the axis of rotation. So where is the torque coming from that's causing the object to rotate? Why does something start rolling instead of just sliding across the surface? So let's think about it. Let's say we have the ground here, and let's say we have some wheel or something traveling across the ground like that. And when the object is rolling, it's basically rotating about its center point. So like in my example here, I was exerting a force like this on the object's center, pointing to the right. So this was the applied force that I was using to drag it forward. There's also gravitational force acting on the object, but the gravitational force, as we will learn, acts on the object's center as well. So that is going to be, let me make these arrows a bit smaller. So that is going to be acting on the object center as well. So that is also not going to cause any torque. So neither of those forces are causing any torque. So neither of those can be causing the object to rotate. So these, let me just erase these because they really don't help us understand this. Where the action is actually happening is down here. The point of contact between where the object touches the ground. Now, we know that at the point of contact, there's going to be a normal force pointing upward. So there's your Fn. Fn is always perpendicular to the surface, remember? But notice Fn points, although it's not acting on the axis of rotation, it points directly to the axis of rotation, which means it has no tangential component. So the normal force can't be exerting any torque either. So it's not the normal force that's exerting torque. What's left? What's left is friction. We haven't thought about friction yet. So the friction force is going to oppose the object's motion. It's going to point in this direction. So there's my friction force. Now, notice it's not acting on the axis of rotation, and it does have a tangential component. In fact, the whole thing is tangential. If you draw that line connecting back to the axis of rotation here, that's not a very good line. If you draw this line here connecting back to the axis of rotation, there's your L. So we're going to have a torque exerted by friction, which will have magnitude FF times the radius of the wheel. And in this case, it's in the negative direction because it's causing a clockwise rotation. So friction is causing a torque in that direction. And notice that's exactly the direction that the wheel will start rolling if you pull it to the right and get it to start moving. As it moves in this direction, it will start rotating in this direction. So that's because actually friction is exerting a force at the bottom, which is causing it to rotate as it travels. So that's why things roll. That's why, like, if you try to, say, drive on a really slippery surface, your tires won't roll properly because you don't have enough friction with the ground. So if you're driving over a slippery surface, your wheels will start to slide instead of roll across the ground because you need that friction force to roll the wheels. So that's where the torque comes from to roll a